Okay, to begin Lab 1, you're going to want to print off the directions for Lab 1, and then you're going to want to print off the answer sheet so you can have them available for you while you're doing your experiment. And the materials that you will need for your Lab 1 will be your textbook, and you might have a loose leaf one, but this is the textbook. You'll need a thermometer, and you will need the ruler. Okay, what you want to do is you want to start off by reading the materials and methods about how the scientific method, it explains the scientific method, it also explains unit of measurements. You can go online to a conversion website, and that will really help you out when you're trying to convert your inches to centimeters and your pounds to kilograms. So try and find a good conversion website online to do those things for you. And so read through your lab first, then you'll grab your answer sheet and you'll start the lab. So what you want to do is you want to take your height in centimeters and your weight in kilograms. So the way that I usually do this is I take my height normally in feet and inches, and then I convert the feet and inches into centimeters. And then I take the weight in pounds and I convert that to kilograms using one of those conversion charts through the internet. And then for the first part, what we want you to do is we want you to take your height and we want you to divide that by your weight, the actual height and weight. And usually it comes out to about 2.5 to 3 centimeters per kilogram, but the expected is 4 centimeters per kilogram. So B, when we ask you to write down whether you support or refute the hypothesis of the 4 centimeters per kilogram is the appropriate expected ratio for you to get, but what you normally get is something about 2.3 to 3 point something. Okay, so then you want to go on to part 2. You're going to take your arm length and you're going to take your height in centimeters like you did before, and you want to take your arm length expected, and basically that means you're going to take your arm length in centimeters and then you're going to times that by 0.4, and you're going to put this in the box, and then you're going to put your actual arm length. And what you want to do is you want to take this ruler and you want to kind of start with a specific area like your armpit or under your arm or on top of your arm, on your shoulder. It doesn't matter really how you do it, you just need to write it down. And you would write how far, how many inches your arm is, and then all the way down to your wrist or your fingers. It is all up to you, so you just need to really write it down exactly how you did your experiment. And then what we want you to do is write down the deviation. So did your expected arm length compared to the actual arm length that you got? So that's what the deviation from the expected. So we want you to take your actual and subtract it by the expected, and you should have some type of decimal there. And then you want to describe your methods for measuring it, the procedure, how you did it, and that should be part 2B. Okay, part 2C, what you're going to write down is, did you support or refuse your hypothesis that the arm length in centimeters is 0.4 of his or her height in centimeters? So basically you want to write down from this part on the A, did it deviate or was it exactly perfect? And we want you to write down, did you support the hypothesis or refuse it? Because there's a certain expected standard, and if you don't meet it, then that's fine, it's not a big deal, but we want to know if you met the standard or if you didn't. Part 3 is your hand temperature, and we want you to hypothesize what goes into the factors of what makes people's hand temperature either colder or hotter, and just hypothesize about the different factors, you know, how cold it is outside or what they're wearing or if they're nervous or things like that. So talk about the factors that might contribute, and then we want your hypothesis about your hand temperature. Okay, so that brings us down to the answer the questions part, and basically those are a bunch of conversion. So I can't really go through exactly which conversion you need to do or anything like that, because we want you to kind of do them on your own. We just want you to critically think here, and we've given you a couple questions to critically think about measurements and conversions. And you want to go through those. At the very end of the questions list, you will find a chart to fill in. And question 5 on the chart starts with your textbook. And what we want to do is we want you to measure your textbook. And you have a ruler here, so you're going to measure it in inches, and then you're going to convert that inches into meters. And then you will convert the meters into centimeters. Okay, so the next thing that you want to measure would be your dining table or your coffee table. And obviously Dr. Mason's not in your house, so we don't know how big your coffee table is, and we don't know that for sure or anything. So we want you to measure it in the inches first and convert that to meters, and then convert that again to the centimeters. Just so we know that you know how to convert, because you're going to be using these techniques and calculations later on in labs, and we need to know that you can do that. So the next thing you want to do is, this one's the unfortunate one, you have to take your mass in grams. And now what normal people do is, we all know how much we weigh in pounds, but we don't know how much we weigh in grams. So what you're going to do is, you're going to take your weight, and then you're going to find that conversion chart on the internet, and you're going to put in your weight and convert that to grams, and then convert the grams into kilograms. So that's all you do for that one. The body temperature, so you can use any regular thermometer for this. I would recommend a medical thermometer. Most people take their temperatures with a smaller thermometer than this, and this is kind of an experimental one, so I would recommend your medical thermometer at home. So you take your temperature, and you want to, because our measurements are in Fahrenheit, and what we want you to show is what is your temperature in Celsius, and then your temperature in Fahrenheit. And last but not least, we want you to place the decimal point where you think it makes the most sense. The first question is asking, it's telling you that Susan is 13,525 centimeters tall, and we want you to critically think about how tall she really could be. Nobody's going to be 13,000 centimeters tall, so what you want to do is go back to your first page and see how tall you were in centimeters, and kind of critically think and see where you should place the decimal point in that. And then the next question would be the soda bottle. And the soda bottle says it contains 59.14 liters of fluid. Now if you think about it, 59.14 liters of fluid is an awful lot of soda. If you consider what a 2 liter looks like, it's about 30 of those. So that's an awful lot of soda, and we want you to kind of scale it down to what you would averagely drink, about 12 ounces or 20 ounces. So we want you to convert the soda bottle and put the decimal point where you think it fits. Okay, and then the speedy driver passes at 16.10 kilometers per hour, and we want you to put the decimal point where it makes sense. Most people don't go 16. You want to do the conversion factor for like 70 miles per hour to kilometers per hour, and find out how fast that is, and then kind of critically think and find out where you should place that decimal point. So once you're done with the conversions, you're all done with the lab. Lab 1's completed.